Good day, everybody. How are you all doing? Today we will discuss about normal distribution. So here I go. So there is no chapter 5. Chapter 6 is on the normal distribution. The normal, a continuous distribution, is the most important of all distribution. It is widely used and even more widely abused. Its graph is bell-shaped, as you can see from the picture. You see the bell curve in almost all disciplines. Two important points about this curve are the curve is symmetric curve about a vertical line drawn to the mean mu. The mu is at the center. The center is the mean where the peak is the highest. And if you draw that vertical line at the center where the peak is the highest, you have two equal halves. The left half is equal to the right half, and that is called symmetrical curve. The area under the curve must equal 1. Okay. And on top of that, I will add another point that the blue curve, which is the normal curve, comes very close to the horizontal axis, but never really touches it, either on the left or on the right. As a matter of fact, on the left, it extends to negative infinity on the far left, and it extends to positive infinity on the far right. The normal distribution has two parameters, two numerical descriptive measures, the mean mu and the standard deviation sigma. If x is a quantity to be measured that has a normal distribution with mean mu and standard deviation sigma, we designate this by writing x is a function, normal function with a mean mu and standard deviation sigma. The cumulative distribution function is probability of capital X less than X. It is calculated either by a calculator or a computer, or is it looked up in the table. In our case, we will be using a calculator. The standard normal distribution. Okay. The standard normal distribution is a normal distribution of standardized values called z-score. The mean for the standard normal distribution is 0 and the standard deviation is 1. When the z-score is used, the z, that is a standard normal variable, follows a normal distribution with a mean of 0 and standard deviation of 1. And it's written z is a function normal distribution, mean 0, 1 is the standard deviation. The value x comes from a normal distribution with mean mu and standard deviation sigma. The z-score tells us how many standard deviations of the value x is above, to the right of, or below, to the left of the mean mu. The following formula is used to find the z-score. Z is given how far the variable x is located from the mean of the, how far away is it from the mean of the distribution. So x minus mu in the numerator, the difference or the deviation sometimes called of x from the mu, the difference of value x from the mean of the population mu divided by standard deviation. That is, z-score is how many standard deviation the value x is above the mean if x is greater than mu. If x is less than mu, then the z-score is negative, and it tells us how many standard deviation you are below the mean or on the left of the mean. Values of x that are larger than mean has positive z-scores, and values of x that are smaller than the mean have negative z-score. If x equals the mean, then x has a z-score of 0. Suppose x is a normal, capital X is a random variable that follows a normal distribution, mean of 5, standard deviation of 6. This says that x is normally distributed random variable with mean mu equal to 5 and standard deviation sigma equal to 6. Suppose that one particular value of the variable is x equal to 17. In that case, the z-score is 17 minus 5. How far 17 is away from the mean 5? Is 17 minus 5 is 12. Divide that by the standard deviation. 12 divided by sigma 6. 12 by 6 is 2 because 6 goes into 12 two times. This means that x is equal to 17 is 2 standard deviation above or to the right of the mean. Notice that 5 is the mean plus 2 times standard deviation sigma is equal to 17. This pattern is mu plus z times sigma is equal to x. So we can find out z score for x equal to 1 when capital X follows, capital X is a random variable that follows a normal distribution with mean 12 and standard deviation 3. So what will you do? You will open your calculator, put the left parenthesis. First is the x value, small x value, which is 1, minus the mean, which is 12. Close the right parenthesis and divide by the standard deviation, which is 3. So what does it mean? It means the small value of x equal to 1 is minus 3.67 standard deviation below the mean. And we can do these problems. I will not worry about it. If capital X, I will discuss some of these problems in the YouTube videos, which I will post. If capital X is a random variable and has a normal distribution with mean mu and standard deviation sigma, then the empirical rule, remember empirical rule, which is valid for a normal distribution or bell-shaped curve, the empirical rule says the following: about 68% of X values lie between minus 1 sigma and plus 1 sigma of the mean mu, within 1 standard deviation of the mean. The z-score for plus 1 sigma and minus 1 sigma are plus 1 and minus 1. Similarly, if you go 2 standard deviation, you cover 95% of the values. And if you go 3 standard deviation, you cover 99.7% of the values. So here is the picture. Mean mu is the center, 1 sigma on the right, 1 sigma on the left, minus 1 sigma. You will cover approximately 68% of the values. If you go 2 standard deviation on the right, 2 standard deviation on the left, you will cover approximately 95% of the values, and so forth. Suppose X has a normal distribution, mean 50 and standard deviation is 6. So 50 minus 6 is 44, 50 plus 6 is 56. So approximately 68% of the values will be located between 50 minus 6, which is 44, and 50 plus 6, which is 56, respectively, and so forth. Here they're asking for X as a normal distribution, mean of 25, standard deviation of 5. Between what values of X do 68% of the values lie? That will be 1 standard deviation. So 25 minus 5 is 20 and 25 plus 5 is 30. So approximately 68% of the values will fall between 20 and 30. So you can do these problems. Again, I will post some YouTube videos. The normal distribution, using the normal distribution. Find areas under the standard normal curve, compute probabilities, etc. The shaded area in the following, that's a blue area, following graph indicates the area to the left of small x. This area is represented by probability of x. Capital X is the random variable less than small x. So probability of capital X less than x is the area. So area under the curve is the probability. Okay, so probability of capital X less than x is the area to the left of the vertical line through small x on the horizontal axis. Probability of x less than x is same as probability of x less equal to. So whether you include the endpoint small x or not, it does not matter. That probability, if you include it or not include it, they're the same. Calculators are used to calculate. So the probability of x greater than x, 1 minus px, So from 1, why are we taking the 1 first? Because total area under the curve is 1. From that, you subtract the area to the left of x, small, capital X less than small x. Then you get the area to the right of the vertical line. Okay. So if the area to the left is 0.0228, the area to the right is this. So in the try 6.7, area to the left is 0.012. So area to the right is 1 minus 0.012, which is 0.988. What does it mean? It means 98.8% of the area will fall to the right of point of whatever the z value is. So here they show you how to do it by calculator. We will do a problem. The final exam score in statistics class were normally distributed, mean of 63, standard deviation of 5. Find the probability that the student selected more than 65. More than 60. So 63 is in the center, standard deviation is 5, and you want to the right of 65. Now, right of 65, the way the calculator will work is you start from 65 as the lower boundary and you are on the right of 65. So your upper boundary will be the infinity, the large value on the right-hand side, which in the calculator we indicate by 1E99. How do you do that? Again, please check out my YouTube video, which I'll post, which will show you how exactly to do this calculation. But at this point, part A, we will do. And if you can follow me, please do so. So I want to the right of 65. So the first thing I do is press the second button on the top left corner. Second button on the top left corner. Then verse button, which is in the third row of the key, calculator keys. Verse, V-A-R-S, second and then verse. Then we will always use normal number 2, normal CDF. Okay. Now we are starting from 65 because we want 65 and to the right of 65. So lower, although the calculator will show -1 E99, that means the very left end of the curve, which is a very large negative number on the left. We're not interested in that. We are going to be on the right of 65. So our right will be 60, lower will be 65. And then upper. Upper will be a very large number on the right, which is 1E99. E stands for exponent. That means 1 followed by 99 zeros. So in the upper, we type 1. Already in the lower, we have typed 65. Upper, we will type 1. Now we have to bring in the small capital E for the exponent. How do I do that? After 1 in the second line, we press the second button and then the comma button, which is on top of the 7 button, about middle of the calculator keys. So second button and then comma button will give me the small capital E and then type 99. Okay. What is my mean? Mean is not 0. Mean is given as 63. And what is my standard deviation is given as 5. So mu is the mean 63, sigma is the standard deviation is 5. I go down to PEST, hit enter twice. And the answer is 0.3446, you might say. Okay, so please check out my video on that. Now in part B, they say find the probability that a randomly selected student scored less than 85. Less than 85 means on the left of 85. So actually lower is the very large negative number. So -1 E99. -1 followed by 99 zeros will be our lower boundary. So again, second verse, number 2. Lower, first I type minus. This minus is next to the enter button on the left of the enter button on the bottom right corner. This minus is not the minus on top of the plus sign. This is the minus on the left of the enter button on the bottom right. So minus first in the lower, then 1, and then second button on the top left, and then comma button, which is on top of the 7 button, about halfway in the keys, about the middle of the key rows. Okay, second comma gives me the E, and then I type 99. So it's -1, second comma, and then 99. -1 followed by 99 zeros. What is my upper? I want to find out what is the area to the left of 85. So I'm going to stop at 85. My upper is 85. My mean is 63. My standard deviation is 5. I go down, put the cursor on pest, hit enter, and then enter again. And the answer is 0.999, almost all the area, okay, under 85, okay. A personal computer is used for office work, at home, research, communication, personal finances, education, entertainment, social network, and a myriad of other things. Suppose that the average number of hours a household personal computer is used for entertainment is 2 hours per day. Assume the times for entertainment are normally distributed, and the standard deviation for the time is half an hour, which is 0.5 hour. Okay, mean is 2 hours. Find the probability that the household personal computer is used for entertainment between 1.8 and 2.75. So again, second verse, number 2, hit enter. Lower is 1.8, upper is 2.75, mean is 2 hours, and standard deviation is half an hour, which is 0.5. And then you go to paste, enter, and enter. And that answer is 58.86% or 0.5886. Then it says find the maximum number of hours per day that the bottom quartile of household uses the personal computer for enter. Bottom quartile means on the left of the center. Bottom quartile means area to the left of the unknown x is 0.25. Quartile is 25%. So bottom quartile means you find the x so that the area to the left of the x is 0.25. So we cannot use normal CDF because the area is given to us. We need to find the value of the unknown x. The area to the left of it is 0.25. So we go second verse. We cannot use number 2. We go down to number 3 in norm. So when area is given, we use in norm. Area to the left is 0.25. Mean is 2. Standard deviation is 0.5. Paste. Enter and enter. And the answer is 1.66. What does it mean? Bottom 25 percentile of the families use the computer for 1.66 hours or less. Okay. You can do this. Okay, 2,000 students took an exam. The scores on the exam have an approximate normal distribution. Mean is 81 points, standard deviation sigma is 15 points. Calculate the first and third quartile. First quartile means 25% of the areas are below that particular score. So again, second verse, and we have to use 3 because we know the area is 0.25. Mu, the mean is 81 and the standard deviation is 1.5. Paste, enter, and enter. And the answer is 70.88 or 70.9. That means 25% of the students scored below or at 70.89. Third quartile means area to the left is 75% or 0.75. Third quartile is 75th percentile. So that 75% of the scores are below that particular score. So again, second verse 3, area is 0.75, mean is 81, standard deviation is 15, paste, enter, and enter. And the answer is 91.1. That means 75% of the students scored at 91.1 or below it. How about the middle 50%? Middle 50% means in the center is 50%. So on the remaining two tails is another 50%. Why? Because the total area under the curve is 100%. Now area in the left tail is 0.25. Okay. And we already found out the value of x below which 25% of the scores fall, and that is 70.88. Okay. And if you go to the right, the center is 50%, right tail is 25%. So below that particular unknown value, below which 50 plus 25, 75%. We already found that in part A2, 91.11. So what is the bottom line? Bottom line is between 70.9 and 91.1, the middle 50% of the scores will fall. I will also be sharing a YouTube video with on this. Okay. So that is the end of the presentation today, but I will be sharing some YouTube videos with you. Please check out those YouTube videos. If you have any question on this YouTube video or other YouTube videos, please send me a comment and I'll get back to you as soon as possible. Thanks for watching. Have a nice day.